Hi, my name's Carla Venar, and I'm a freshman in imaging science.
I'm Sharonica, you guess?
I'm Bobby Mancini.
Mason Wallers.
This is the Freshman Imaging Project. It's a class where they give a bunch of freshmen in imaging science and motion picture science a task, and we kind of just work together and work with faculty to learn as much as we can and see what we can get done by Imagine RIT.
I really enjoy physics and computer science, and I stumbled upon imaging science and thought it was a good synthesis of the two.
I was very interested in computer vision in high school, so when I toured RIT and heard about the imaging science program, it seemed right up my alley.
I thought it was really exciting. It was something new that I hadn't done before. You know, this idea of the students we're pushing ourselves and we're setting our goals, and that was exciting.
As soon as we heard what the problem would be, it sounded like it could just be an easy tracking problem with OpenCV, but then as 1 week went by, it became more complicated, and I wasn't sure if we'd be able to do it.
By Imagine RIT, we wanted to be able to show that we could track a foosball live as it, moved around a table. My part in this project has been the basic tracking of an object. We've used that code a bunch of times for getting coordinates of tracking a moving object across a field.
Our camera opens up and it takes an image, or it takes a frame of the foosball table. It then looks at all the colors that we give it. It draws a circle around the ball. It gets the X and Y coordinate of where that ball is relative to the rest of the table. Then with a WebSocket, we send the X and Y coordinates to Unreal Engine, and then it's visualized in 3D with Unreal Engine, and you get to watch it with your VR headset.
I am currently on the table tennis team, which is tracking table tennis. So for the table tennis system and how it tracks the ball and kind of how it works, right now we are somewhat set on detecting the color of the ball. We figured out things like if we change the settings of the camera, we can distinguish the orange color of the ball from other hues of orange. After we do the color detection and the camera calibration, we should be able to use simple geometry and math to hopefully determine the X, Y, and Z coordinates of the ball in relation to the table tennis table.
I think the most difficult aspect of this project was getting all the components together, especially because each of us is learning something new, and so what we're building isn't necessarily always able to be integrated into the other components. So we had a lot of issues with this processor not working with this code, or this not being able to work with that. So that probably caused the most issues.
I didn't think real-time tracking was going to be possible, even at the beginning of the second semester. I thought that'd be way too difficult, but that was the main success that we got done. Most difficult thing was taking initiative and then kind of pushing your own path forward with what you had to do.
I'm not surprised that we finished, because I thought pretty much early on that we'd have something to show. But I am surprised a lot of things have been added last minute, which is super cool. So I'm not surprised that we got it done. I'm very surprised how it turned out.
I tell future students to work outside of their comfort zone. Even if you think that you've never done something before, jump into it anyway, because you'd be surprised how much you enjoy that which you don't know. A lot of people jumped into things that they were not comfortable with, and the team reaped the rewards of that, and they reaped the rewards of that as well in their own personal lives. So I definitely say keep an open mind and jump into that which makes you uncomfortable.
One of the biggest takeaways is how much a group of people can get done when they really, well, one, when they have a deadline, and two, when they really want to get something done.